let's take a look at the next problem we have in the sense of this particular problem. So for instance, as you can see, if you glance through this item here, or if you glance to the question, they ask us to find the mean, they ask us to find the standard deviation, and then they ask us, can we interpret our data or our information? But if you look at our data right here, forget about what information is behind this data. We can glance through this thing here. We see that all of our probability does not have a negative number, and all of this probability does not have a number bigger than 1. So we see, glance at this thing here, we can see that this is our probability distribution. And if you were to add this, right, if you were to add the 0.7, 0.15, 0.1, 0.03, 0.02, if you add them together, it's equal to 1, and that is our probability distribution. So let's take a look at what information, what data that they present to us, right? So they tell us that this x, whatever this x is, 1, 2, 3, 4, 5, is the number of occupants in a randomly chosen car in the stretch of highway during the morning commute hour. So again, in the car, there are 1 person, there are 2 people, 3 people, 4 people, 5 people, right? And then the probability of 1 person, right? The probability of 1 person is 70%. The probability of 2 people is 15. The probability of 3 is 10. And as you can see, the bigger the people, the more people, the less the probability, right? So it's not symmetric, right? It is kind of skewed to the right, more of them at the one level. But looking at this thing here, this is what they ask you. If we randomly select one car, right? If we randomly select one car, what is the probability of that car have 2 people in it, right? This is what they tell you for A. What is the probability of 2 people? If we select one car on this certain highway, what is the probability of 2 people in it? So based on this distribution, based on this information, do you agree that 2 people is 0.15? Meaning 15%, right? 15% based on this data, 15% chance that you pick out a car and that car have 2 people. And similarly, they ask you find the probability of more than 3 people. Again, more than 3 people, meaning we have to have 4 people and 5 people. So more than 3 people, all we need to do is take the 0.3 and the 0.03 and 0.02. And as you can see, this thing here will give me 0.05, meaning again, roughly 5%, or actually 5% is have 3 or 4 people in it. I mean, 4 or 5 people in it, right? 5%. So in the sense of this item here, we can see that all we need to do is we extract out the information based on the question they've given us, or based on the question that they present to us, right? So find the probability of car that have only 1 person in it, 1 occupant. So 1 occupant is easy, right? Similar to 2, it's just that now they write it in wording instead of writing symbolic P of 2. They say they spell it out. We have 1 occupant, which is 0.7, 70% that have 1 person in it. And similarly, find the probability of a car that have fewer than 4 occupants. So fewer than 4, meaning again, we do not include 4, we include the 3, we include the 2, and we include a 1 person. There's no car have 0 people because it does not drive, right? So in terms of this thing here, we just take 0.7 plus 0.15 plus 0.10. If you add them together, meaning 95%, right? 95% of the car, based on this information, 95% of car that drive in this highway will have less than 4 people in it, okay? So again, that's the idea of this. The idea of this probability distribution is they have some data and they distribute the probability throughout your data. And the total probability have to be equal to 1. So now going to the last 2 questions, this is what they ask you is compute the mean and compute the standard deviation. So how do we find the mean and how do we find the standard deviation without using the formula, right? And if you remember on this thing here, we can use our calculator. And to use our calculator, this is what you need to do is you need to press stat and you need to press edit and then type in L1 and L2. Reminder, L1 is your data and L2 is your probability. And then once you have your data in L1 and L2, all you need to do is press stat and then calculate and one for stat. And then you just press enter, right? So if you look at this thing here, let's go back to our calculator, or let's take a look at this calculator that I have. So reminder, ladies and gentlemen, if you hit stat and then you hit edit, this is what we have is you hit stat and you hit edit. Reminder, when you edit, if you have your data and you want to clear your L1 or L2, you go to highlight your L1, you hit clear and then enter to clear L1, or vice versa, L2, you hit clear and then enter. Do not hit delete. If you hit delete, as I just did, everybody see that if you hit delete, your L1 and L2 delete it out. Meaning again, you just delete the whole row L1 and L2. So if you happen to miss L1 and L2, or if you happen to delete your L1 and L2, to get it back, you have to hit stat and go to setup editor, option number 5, setup editor, press enter and enter again. If you do that, your L1 and L2 should come back. L1 and L2 is here. So again, if you happen to delete your L1 and L2, you hit stat, go to option number 5, which is setup editor, you press enter and then enter again. So let's take a look at our data. If our data, this is what we need to put in. My L1, I need to press in 1, 2, 3, 4, 5. Right? 1 person, 2 people, 3, 4, and 5 people. And my L2, I have 0.7, 0.15, 0.10, 0.03, and 0.02. So make sure that you have 5 data on your L1, 5 data on L2, and they all correlate to each other, 1 for 1.7 and 0.15, 0.1, 0.03, and so on. So everybody see that my L1 is my X, my probability is my L2. I hit stat once I have my data and I scroll over to calculate. You press over, calculate, and we choose 1 volt stat. And if you choose 1 volt stat, make sure that your L1 is your list and your frequency is your L2. And then you go to calculate. And if you hit calculate, this is what you have. And again, ladies and gentlemen, the 2 information that we need, is X bar. The X bar is your mean, and the sigma, which is your standard deviation. So X bar is 1.52, and that is my mean is 1.52, and the standard deviation is 0.9325. As you can see, the calculator help us, or the calculator give us the 2 things that we needed. The 2 things that they asked us, in this case, they asked us what is the mean. And if we did the mean, or if you look at your calculator, your mean is 1.52. And if they ask you for the standard deviation, which is in this case, they ask you for the standard deviation, your standard deviation is 0.9325. So question here, any question on how to utilize your calculator, any question how I got my mean from the calculator, or how I got my standard deviation from the calculator? And again, if you have, if for those of you who have 83, if you have TI 83, after you hit, if you have TI 83, this is what you guys need to do is, if you hit 1 volt stat, all you do is you have to manually hit L1, which is second 1, comma right here, second number 2 for L2. So make sure that if you have the TI-83, is basically you have to manually type in L1, comma L2 and not have that prompt. Okay. So question with this item where I have my mu 1.52 and my standard deviation 0.9325. Question on any of this thing here? And to analyze your information, they say to save energy, the goal is set to have the mean number of occupants to be at least two people per car. Have this goal been met? Have this goal been met? The mean have to be at least 2. As you can see, the mean that we have is 1.52, meaning between 1 person and 2 people, right? We don't have half of a person, I agree, but the average, the mean here is roughly between 1 and 2, but at least 2, meaning have to be 2 or more. So as you can see, in this case, the goal have not met. Why the goal have not met? Because when we calculate, the mean that we calculate to be 1.52 to be exact, but 1.5, meaning is somewhere between 1 and 2, right? Sometimes you have 1 person, sometimes you have 2 people, but somewhere between there, we don't always get 2 people. We don't always get 2 people. And here they ask us that at least 2, meaning you have to have at least 2 people or more, right? So because 2 people or more, we have not met that goal. Okay, so that's the idea, is we look at our information and we try to analyze it, right? We try to analyze and answer the question. Okay, so the idea is the mean is not 2, so we not at least 2. Okay, so if it's 2 or more, then we say yes, we met the goal. But in this case, based on our information, based on our data, we have not met this goal. Okay, so once we have this, if you remember what I mentioned before our midterm, if you remember, I told you guys that if they ask you to find the mean, is the same as if they ask you to find the expected value. The expected value is the same as your mean if you have a probability distribution. Okay, so most of the time, or this is what you guys need to do, is if they ask you for expected value, well, you have to create your probability distribution. So to create the probability distribution, this is what I tell my students, is for any time you have expected value, you will have 2 items. You will have some gain and you will have some loss. Okay, and if it's a gain, we will put a positive because it's a gain. And if it's a loss, we will put a negative value to illustrate that it's a loss. Okay, and then from your gain and from your loss, you will have the probability of your gain and the probability of your loss. So let's take a look at the information, the lottery game that we have. So in New York, in the New York State number lottery, you pay $1 and pick a number from 000 to 999. Any number between, meaning 000, 001, 017, or 871, any number between those 3 digits, 000 and 9999. If a number come up, you will win 500, which is a profit of $4.99. If you lose, then you lose $1 that you pay, right? The probability, your probability of winning is 0.001. What is the expected value of your profit? What is the expected gain? Or what is the expected loss? So one thing I want to point out is, remember, the gain is your profit. I agree right here, you win 500. You win 500, but because your investment, you invest in $1. Because you invest in $1, so your investment you have to deduct from your winning. So in term, the net gain or the profit is only $4.99, not 500, because originally your dollar is yours, right? So you get 500, but within the 500, there is your $1. Okay, so the profit here is only $4.99. They spell it out, so that's good. And the loss, which is if we lose, we were to lose $1. So everybody see where my $4.99, which is profit, the gain, and the loss, which is -1, because it's the $1 that we will lose if we were to lose. And the second thing we have is the probability. They tell us the probability of winning, which is gaining $4.99, is 0.001. The probability of winning, and if you win, you will gain, and the gain, you gain $4.99. And if that is the probability of winning, do you agree that the probability of losing is 0.999? How did I get that? If you remember the total probability is 1, right? So if I know that the total probability is 1 and I know that the probability of winning is 0.001, do you see that in order for me to find a remainder, all I need to do is take the total, which is 1, the total probability, minus 0.001. And if I do that, that is where I get the 0.999 come from, okay? And that is how I got the 0.999. So everybody see a question in terms of how I got the 499, negative 1, 0.001, and 0.99. And if we were to have this information, everybody see that now I have my X value, right? I have my X value and I have my P of X value, meaning do you agree that I can put in my L1 and L2? Reminder, to cancel your L1 or L2, you click clear, not cancel. To clear your L1 and L2, you select L1, you click clear, and you clear them out. So again, once we have this, and that's your goal, is you construct your probability distribution. And in this case, reminder, if you're using the negative, make sure that you're using the negative symbol down here. This is your negative symbol. Do not use the minus, okay? So negative 1, that's what we have. 499, negative 1, and again, the probability 0.001, and the probability the other one is 0.999. So if we have this, as you can see, my 0.499, negative 1, 0.001, and 0.999. And once you have that, as you can see, the calculation is easy. Once you have the L1 and L2, which is your X value, and then the probability, you press enter, you calculate them, and everybody see that my X bar, my mean is negative 0.5. What does that mean, negative 0.5? Well, negative meaning that's your loss. Meaning in the long run, you expect to lose 50 cents on a dollar for this game. For every dollar you spend on this game, you expect to lose 50 cents. Okay, so to find the expected value, just to be in short, to find the expected value, all you need to do is to find your mean as the same as before. Like I mentioned, they just changing the name, the operation and the item is the same. But the goal here is not to, the goal here is to find the mean, but the objective that you need to do is you need to construct your probability distribution. Okay, so first of all, well, let's do one more. Let's do one more problem, and then I take any question you might have. As you will see, the next problem is very similar to this one here. Kind of inexact. It's just a different number, right? In this New York State number lottery, you pay $1. Same thing go. You pay $1 to play the sum of the number that come up to be 13. So this thing here probably not a lottery game, probably just the dice, right? You have 2 dice and you roll this dice. You pay $1 if the 2 dice you roll and they add up, well, not dice, sorry. The 2 dice cannot add to be 13. Whatever this game is, basically 2 numbers add up to be 13, right? So they give you the probability of winning is 0.075. And if you win $6.50. Remember, you win, but that's not your profit. In order to qualify for you to win the $6.50, you have to pay $1. So when you get the $6.50, that's what you win. But the gain, the profit is only $5.50. And again, if you lose, you only lose $1. And same question, they ask you, what is the expected value? So to do this expected value, this is the 2 things we need is we need to know how much we gain. And in this case, we know that we gain the profit is $5.50. And we need to know how much we lose. And in this case, we will lose $1, which is -1. And what is the probability of winning? The probability of gaining, the probability of winning is 0.075. And again, how do I find the probability of losing? all I need to do is take 1 minus 0.075, right? The probability of me losing is this right here. The probability of losing is 1 minus the probability of winning, which is 0.075. And if I take that, I will get 0.9275, right? If I add this, this is 0, this is 0, this is 0 is equal to 1. I have the probability distribution, ladies and gentlemen. So once we have this item here, do you agree that all we need to do is press in our calculator, right? Using our calculator, and our calculator tell us what do we do in our calculator. We go to L1 and L2, and in L1, instead of put 499 like last time, we have 5.5, and again, -1 is the same. My probability is 0.075 and 0.925. And again, looking at this thing here, my L1 is my X, my value, my gain and my loss. My L2 is my probability. I hit calculate one var stat and then calculate this item here. As you can see, this game is actually worse than the previous game, right? This thing here, we have a -0.51, meaning in the long run, we expect to lose 0.51 cent. Meaning again, for every dollar you spend on this game, you expect to lose 51 cents. You know, you see that the probability here, you say, well, the probability here is bigger than the previous one. Yes, the previous is 0.001. But because the payout is more, right? The payout is more on the previous one. So that's why the other one is actually a better game. It's still a losing, right? You still expect to lose, but you lose less, right? So in the sense, first of all, question in terms of how I have this number, and from this number, how I have the answer. Any question here? Well, similarly, let's take a look at, instead of gambling, right? Instead of gambling, let's take a look at what if there's an investment involved. What if you are a financial counselor for this lady? Or is it a lady? Yeah. This lady planning to open a business, right? And you calculate and you have this information. Would you advise her to start this business or do not start this business, right? So if you look at this item here, this what they tell you is an investor considered to have a 10,000 investment in a startup company. She estimates that she have a probability of 0.25 of 20,000 loss, meaning she expects to lose 20,000 and the probability of 25%. The probability of 20% of 0.2 of 10,000 profit. The probability of 0.15 is 50,000 profit, and the probability of 0.4 of breaking even, meaning 0 profit. What is the expected value? So if you look at this thing here, unlike our lottery game, last time we only have 2 value, win, lose. This thing here have multiple value. And if they have multiple value, what can we do? Well, just list what they give us. Do you agree that we have a negative 20,000? That's why it's negative, because that's the loss. They tell us that C have a probability of 0.25, which is, that's my probability, and the loss, because of the loss, we have to put in a negative. So the loss is negative 20,000. 0.2, which is 0.2, and the profit is 10,000, and vice versa. 0.15, the profit is 50,000, and 0.4, the profit is 0. Reminder, the amount doesn't matter what the X value is, as long as your probability is equal to 1 when you add them all up. And in this case, you can see that if you add all this thing up, it's equal to 1. And the other thing that some of you guys say, well, wait a minute, Mr. Shuang, what does this 10,000 investment startup company do? What do we do? Well, this number is just extra, right? It basically tells that she have the 10,000 she can put in. And you know, if why does she lose in 20,000 if she only put 10,000? Well, you know, after you do stuff, probably you put more money into the business to keep it up or whatever you're trying to do. So sometimes you have to analyze and ask yourself what number we needed, right? So again, she have a loss, meaning maybe she put more money, but the probability put in more money and lose everything, right? The 10,000 investment and an extra 10,000 is 25%. Okay, and again, she profit 10,000, meaning she gain 20. No, not gain, but the business make 20,000, right? She got her 10,000 back, and then an extra 10,000. But anyway, because they say profit, that's what we want to use. So as you can see, once we identify this, in this case, we have 4 numbers: -20, 10,000, 50,000, and 0. And if you press this into your calculator, which is L1 and L2, you use the edit L1, L2, and then you do the stat, calculate one for stat, L1, L2. Do you have the profit? Do you have the mean is 4,500? Meaning, this is what they tell you, that in the long run, she will get 4,500 on average, right? On average, she would get that, right? Maybe the first year she lose some, maybe the second year she gains some, but in average, in the long run, she will get 4,500 profit. So again, if you look at this thing here, that's a good investment, right? You invest 10,000 and you get almost half of them back, right? Almost half them back. But again, this is an idea in terms of the expected value. Question, anybody does not have the 4,500 in profit using your calculator? Or anybody does not see where I got my number from? All right. If you don't have question, let's take a look at the next item that we have. This thing here, the problem come is, ladies and gentlemen, if you read this problem, you say, well, this problem is the same as the previous one. But one thing is, this problem is a little bit different in the way that you are the insurance company. You are trying to see what is the company gain and what's the company loss, not yours, right? If you were to be, or if I were to be this 80 years old man, right, and I pay this premium, right, and it's not compute about my gain or my loss, it's compute the company, right? So if you look at this item here, they say that the insurance company sells a 1 year's life insurance policy to the 80 years old woman. The woman paid this premium for this 1 year, 1,500. If she die within a year, the company will pay 25,000 to her beneficiary. According to the U.S. Central for Disease Control, CDC, and Prevention, the probability of the 80 years old woman will be alive 1 year later is 0.9516, meaning she makes to her 81st birthday. Let X be the profit made by the insurance. So now you are the insurance, right? Find the probability distribution and find the expected value in terms of profit or loss. So in terms of this thing here, hopefully you guys see this item here. The company gain, what does they gain? Well, if woman make to her 81st birthday, the company will gain 1,500, right? 1,500. That's the gain. The company will take that as a profit. They will sell another policy from 81 to 82, but in terms of 80 to 81 is done. That 1 year's premium is gone, right? If that lady happened to die within her 1 year, then the company have to pay out 25,000. But reminder, what does 25,000? Within the 25,000, right? Within the 25,000, see, they pay out the 25,000, but because within the 25,000 is her premium, right? The company not pay out the whole 25,000. They only pay out the, they pay out 25,000, but within the 25,000 is the 1,500 from the woman, right? So basically you have to take the 25,000 minus this 1,500, and that is where the loss, the total loss is 2350, right? Because again, 23,500 is the total loss for the company payout. And how I get that? I just take the 25 minus the woman premium, right? Because originally the woman got that 1,500, right? So I just returned the 1,500 it just to the beneficiary, right? So looking at this thing here, the other thing I have, or if you look at this item, they tell us that the probability of this woman make to her 81st birthday is 0.9516. Now, what is the probability she does not make it? Well, the probability she does not make it is we take 1, which is the total probability, minus 0.9516, right? And if I minus that, as you can see, the probability of she die within this years and does not make to her 81st birthday is 0.0484. And I take 1 minus that, right? Because remember, the probability distribution, the total probability have to be equal to 1, right? So again, the probability still alive within 1 year is this much. The probability die within 1 year is this much. And if you can see this value, if you have this value, again, all you do is you put in L1 and L2, and then you calculate just like before. So the math is not difficult. Hopefully the math is not difficult. How do we take the word and turn it to the math that we know, right? And that's your problem, or that's your objective. And if you do this thing here, everybody see that in the long run, the company, the insurance company will gain $290, right? Meaning for every policy that they have, they just took $290 as their profit, okay, in average, okay? So if you think about this thing here, the probability, think about this. Let's say that this company, they sell 100 policy. There is 180 years old woman, and they pay this much to the company. So if they pay 100, do you see that if they pay if we have 100 women, the company will make that much, right? In terms of the policy, this is how much. If we sell 100 policy to 180 years old woman, the company will make $150,000. And take a look at this item here. They say that with the probability, meaning if we have 100 women, and the probability that we have is roughly 5%, right? If they die, meaning if they die in the sense of 5%, 0.05, just make it even, meaning if we have 100 women, 5 of them will die, right? And if 5 of them will die, do you agree that 5 times 25,000, right? What does that give us? What does 5 times 25,000 give us? Do you agree that 5 times 25,000, this thing will give us 105,000, right? Meaning, again, if we were to sell for 100 policy, and based on the probability, based on what we conduct, right? Roughly 5% of this lady die. And again, based on that, because of that, we know that we pay out this much. But we still gain 25,000, right? Meaning, again, in average, we still gain something, okay? Worst case scenario is within that years, the whole 100 women that we sell die, And then that's when we suffer the loss, right? We have to pay out 250,000, right? But again, in the sense that we lost 100 extra thousand, right? But based on the probability, based on the information we gather, that's rarely very unlikely to happen, right? But again, to be in short, the average or this expected value is basically tell you in average what should we expect to gain. Okay, so in our item, based on this thing here, the probability of the woman live within 1 year is very high. So because it's very high, we don't risk that much, right? And again, because of this thing here, we just, we don't gain that much either, because the premium we take is not that high. If we want to gain more, we just increase more premium, right? So again, looking at this thing here, question with this question in terms of this item here, in terms of how we find the expected value using or to find our mean.
Finding the probability distribution, is that just making the table?
Yes. Yes. Okay. Again, probability distribution, they basically tell you that you have some value and you have the probability distributive to those values. That's it. And reminder, the probability distribution just tell you that the probability have to be equal to 1, right? And the probability, each probability cannot be negative and cannot be bigger than 1. Any other question here? All right. If you don't have question, let's take a look at 5.2. And reminder, I told you guys that 5.2 is chapter 5 is only 5.1 and 5.2. And 5.2, this is where we head into, or this is what we have, is we will deal with a binormal distribution. And when we begin with the binormal distribution, it will be a little bit confusing, but bear with me here. There is a light at the end of the tunnel. So if I have time, by the end of today, you will see that is a little bit doable, or very doable. Okay, but let's take a look at what is a binormal distribution. So the binormal distribution have to have this criteria. Without this criteria, they are not a binormal distribution. Okay, the first criteria is they have to have a fixed number of trial. Meaning, for instance, if I flip, if I were to give you a test, let's say if I give you a true and false test. If I give you a 20 question true and false test, meaning we have to have a fixed number of questions, a fixed number of try, meaning you have to know how much you do whatever the experiment that you want to do. You have to know the total number of experiment we have. And in each experiment, you will have only 2 outcomes. You will have a success or a failure. In my case, the true and false question, you either have a true or a false answer. The other thing is the probability of each of them, the probability of each trial is the same. As you can see, each question, you have a fair chance, right? Unless you know the material. But if you don't know the material, you have a fair chance for each question, because each question, you will have 50% of get right or wrong, right? True or false, 50-50, right? And each question or each trial, they are independent, meaning they do not affect one another. Right, we cannot base on question 1 to answer question 2, right? So again, each of them are independent. So looking at this thing here, there are a few things that you will see that you will need to identify. Is you will need to identify your X, which is the number of success that you want, the number of items that you want, and you will identify the N, which is the total number of trial you have. And the P in this case, the smaller P that we have, is the probability of a success. So if we base on the true and false question, the probability of success is 0.5. Okay, because again, the probability you get the question right, successfully answer the question right, will be 50%, 0.5. Right? If it's a multiple choice question, if it's 4 choice, multiple choice question, the probability of you get success will be 0.25 because 1 out of 4, right? So 25%, right? So that's the idea. The idea is for any item we have, we need to have a fixed number of items. We need to have either success or failure. And then we need to know that each of them are independent from each other. Okay, so given those criteria, look at those items here, they ask you if we were to have this item, can you identify if they are a binormal distribution or not a binormal distribution? So for number one, they say the coin is tossed 7 times. Let X be the number of head. So looking at this item here, is this a binormal distribution? Hopefully you say yes, because if you toss a coin, is have a fixed number of trial. What is the fixed number of trial here? We are tossed the coin 7 times. And again, we have a fixed number of trial, and each trial, you flip the coin, you either have a head or a tail. If you want a head, land on the head is success. If it's land on the tail, failure, right? So again, the X is the number of head that we want to obtain. Well, we want to obtain 4 head, then you look at your trial, and then you see how many times that 4 head come out, right? And what's the difference between 1 and 2? Well, number 2, they ask you a coin is tossed until the head appear. We don't know the fixed trial, right? Because the first time the head can appear, or the 10th time the head can appear, or the 50 time. If my luck is bad, I can flip the coin 50 times. This might not be that much, but it can happen, right? So in the sense that we don't have a fixed number of trial, and because we don't have a fixed number of trial, this is not a binormal distribution, okay? And then if you look at number 3 and number 4, well, number 3 and number 4 is a little bit different, and I want to give you this thing here because on Connect Math, they throw this item at you guys, and it's basically tell you this item here, ladies and gentlemen, is if you have, in this case, we have a fixed number of students or fixed number of items, right? And if we are dealing with a sample and population, the sample that you have to be less than 5%. In order to be considered as a binomial distribution, if we were to use a real life situation in terms of our data, whatever our data is, in order to be considered to be a binomial distribution, the percentage that you have to be less than 5%. If you take a look at what we have here, our data that we have on number 3, our data on number 3, we have 10. If you take 10 divided by 25, right? We have 10 students and we take 10 divided by 25. Everybody see that this is equal to 0.4, right? Which is 0.4, meaning 40%, right? This is 40%, which is bigger than 5%. And if you take the number 4, if you take 10 divided by 300, this thing will give you 0.03333 in the sense that this thing here is roughly 3.3%. So in the idea of this, or in the nature of this particular item, if your sample, if you take the random sample and this random sample is less than 5% of the population, then we consider that this is a binomial distribution. If it's not, then we say it's not a binomial distribution. Okay, so that's the only thing that we have, or the only thing that you need to consider in terms of this item here. But most of the item that we have is, you have to ask yourself is, do they fit this criteria? Do they fit this item here? Do they have a fixed number of items? Do we have either true or false? Success or failure? And each of them have the same number, or the probability is independent from each other. Okay. And again, the number 3 and number 4 is just that if we were to have a real life situation, then we can use, or this is the criteria, is they have to be less than 5%. Okay. So the question, the main question they won't ask you is how to identify if it's a binomial distribution or not a binomial distribution. The question, or the main question they will ask you to do is, can you find the probability if we were to have a binormal probability distribution? Okay, and to find this binormal, to find this probability, this is what we have, is we have NCX, which is NCR prior to our item, which is the total number of items we have, and how many are we choosing. Multiply to the probability of success, which is your P, the probability of success, raise it to the X, multiply to 1 minus P. In this book, in this author, he used 1 minus P, raised to the N minus X. And again, the X is the possible outcome that we want, the possible item that we want. And the X can be 1, 2, 3, up to N, or 0, 1, 2, up to N. Okay, so as you will see, in order for us to use this formula, so let's take a look at the typical question, right? Your typical question, and one thing that you will see that this is what you guys need to do a lot of time in this 5.2 problem is you need to identify your N, the total number of items we have, or the number of try that we need to do. You need to identify your P, which is the probability of success. And you need to identify your X, which is how many that we want to be success, okay? So if you were to look at this particular problem, just like I mentioned to you guys earlier, let's say that on next Thursday, you come to class and I give you a true and false test based on chapter 7. We haven't mentioned about chapter 7. You don't know anything about chapter 7. You just randomly guess this test, right? So I give you this 10 question test, 10 question true and false test on chapter 7. And without knowing anything, you just go and say true, false, false, true, true, false, false, true, true, false, right? Just randomly guess or bubble in the scan chart, right? So now they ask you this thing here, let X be the number of questions you have correct. Now, in part A, they ask you if you were to go in and randomly guess it, what is the probability that you have exactly 4 questions correct? The probability of 4, meaning you go in there, you guess, and you have exactly 4 questions correct. About to see the question here, right? Miny, 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 more, right? You just bubble in and then run it through. Now, what is the probability of you have exactly 4 of the question, 4 out of the 10 questions correct? So in this case, first of all, we know that we need to identify our N. What is the number of trial we have? Well, we have 10 questions. That is how many trial you get to do, right? You get to bubble in 10 of them. What is the probability of, for each question, what is the probability of you get it right? Well, 50-50, right? True and false. You only have either true or false. You go in there, you bubble true, false, true, false, false, true. You have 50-50, randomly guess for each question, right? 50-50. And do you agree that looking at this item here, this is our formula, probability of X, in this case, probability of 4, meaning exactly 4, will be NCX multiplied to PX multiplied to 1 minus P and to the X, right? So what is my X? Well, as you can see, my X is basically 4. Wherever my X is here. So now instead of X, they put 4, meaning again, you go in, you take this test, what is the probability you get exactly 4 questions correct? And looking at this thing here, do you agree that all we need to do is plug into my formula? Probability of 4, probability of exactly 4 is equal to 10, which is my N, C4, which is again NC4, multiplied to P. What is my P? My P is 0.5 raised to the 4 power, right? Multiplied to 1 minus P raised to 10 minus 4. So everybody see where my P, where my P, and where is my X and N came from. And if you were to have this, if you were to have this, and let's take a look at this item here. Reminder, how do we do the NCR? This is what you need to do is you need to hit 10, you hit to go math and go to the probability, which is, this is my NCR. So 10 NCR 4, that's what I have, 10 NCR 4. So 10C4 will give me 210. And now what do I have? I have 0.5 raised to the 4 power, which is 0.5 carried to the 4 power. This is what I have, 0.0625. And then 1 minus 0.5, which is the other 0.5, raise it to 10 minus 4, which give me 6. 10 minus 4 will give me 6. That is what I have. And then all I need to do is I take all this number, and if I take all this number you saw, if you take all that number and multiply together, everybody see that this is what we have is 0.2051, right? Meaning the probability that you take this test that you don't know anything about and you randomly guess true, false. You randomly guess this 10 question and you have exactly 4 of them correct is roughly 21% or 20%, 20.5%, right? Not bad, right? If you just guess it and get 4 of them right, meaning again 4 out of 10 questions, so 40% on your test, right? You have 20.5% of get 40% on your test. That's the question. That's what you answer here. Okay, and looking at this item here for B. For B, they ask you is what is the probability that you get fewer than 3 questions? Remember, reminder, fewer than meaning we do not include the 3. Fewer than meaning the 2 question, the 1 question, or the 0 question, meaning you randomly guess this 10 question, and then you have either 2 questions correct or 1 question correct or none of the question correct, right? That's what fewer mean. And if you were to do this thing here, and this, ladies and gentlemen, meaning again, what does this mean? This means that we have to do the 2 question. We have to do the x with 2, and if you do the x with 2, this is what you need to plug in, which is 10C2. The 10 is lowercase, 10C2, and then you plug in all of this item here, and this is what you have for the 2, and then you have to do for the 1, and if you plug it in, this is what you should have for the 1, and then you have to do for the 0, meaning again, this right here tell me that I have exactly 2 questions correct, which is roughly 5, not even 5%, 0.04. I have exactly 1 question correct, 0.009, and I have 0 question correct, 0.0009. And if you take all this thing and add them up, because remember, fewer than 3, you have to take the 2, the 1, and the 0. And if you take all of those and add them together, this is what you have is probability of you get fewer than 3 questions correct is roughly 0.0547. So roughly 5%, right? A little bit more than 5% that you have either 2 questions correct or 1 question correct or 0 question correct. Okay, so the idea of this question is to tell you that fewer than is meaning to basically you do not include the 3. And as you will see later, ladies and gentlemen, that when you do this this item here, you have to ask yourself is, do you include the endpoint or exclude the endpoint? That is one of the major question, or one of the major item that you need to ask yourself is, do I include the 3 or do I exclude the 3? Okay, keep that in mind. Fewer than 3, we do not include the 3. We only do the 2, the 1, and the 0. And vice versa, for C, they say that in order to pass this thing here, you need to make at least 7 questions, right? Meaning, again, you need to have 70%. That's a passing grade, right? A student must answer 7 or more questions correct. Reminder, 7 or more, meaning at least 7, meaning 7, 8, 9, and 10, right? Would it be unusual for the student to pass this, right? So this is what they ask you is, if you were to go in and randomly guess this thing, if you were to go in and randomly guess this thing here, and again, I skipped this thing here because I want to point out, I want to show you the idea of the question, but the calculation is the next item, you will see that the calculation is easier. And like I say, at the end of the tunnel, the light will be very bright, right? So we will not, this is probably the first and only time you will see this formula. And this is probably, you will never use this formula again once we show you the other way, the two other way, okay? So looking at this thing here, just to remind you that 7 or more is the same as at least 7. And remember, 7 or more, meaning we include the 7, meaning we need to know what is the probability of get at least 7 questions correct, get at least, not 7 at least, but get exactly 7 questions correct, exactly 8 questions correct, exactly 9 questions correct, and exactly 10 questions correct. And if I plug into my calculator, this is what I have. This is where my number comes from. And all I need to do is I need to add all this thing up. And if I add them up, this is what I have is 0.171875, meaning roughly 0.17, roughly 17%. Meaning I have 17% chance of me guessing and passing this test, right? I have 17% of me get at least 70% on the test, or 80%, or 90%, or 100%. Okay, so in the sense, or in this idea, will this be usual or unusual? Reminder, the cutoff is 0.05, and this thing here, they will be usual, right? They are not unusual, meaning usual, because as long as, remember, the cutoff have to be less than 0.05. In this case, we have more than 0.05, meaning it's usual, meaning there are a chance that is happen, right? There are a chance that you can get, you can pass this test without knowing the material and just randomly guess it, okay? So one thing is, you would say, whoa, all this formula, all this number, how do I plug it in? Well, one way is, like I mentioned earlier, you probably will never use in this formula after you saw this item here. So one thing is, this in your book and on your Connect Math, in your homework, they have this table they call a binormal probability distribution table. And the binormal probability distribution table is basically tell you that there are some guy did this for you. Some guy that go in there and say, well, if this is the formula and this is all the time, well, we can just do it and have this chart. So if you look at this item here, this is your 10 multiple choice question, right? Your 10 multiple choice question is this, the n is 10, right? And the x, this is, remember, this is what they tell you is the x is 4, right? Remember that the first question they ask you is find the probability of exactly 4 questions correct. That's your x, right? And what's the p? The p, they tell you that for our case, the probability is 50%. So some guy go in and say, well, if this is the case, then this will always happen, ladies and gentlemen. Remember, we calculate this before. We calculate and we have 0.2051. This table give us 0.205, meaning we have this item. We don't have to calculate it. If we saw that this is the probability and this is the n and this is the x, we can just extract the information from this table because some guy go ahead and did this for you, right? And if you were to look at and you say, well, Mr. Chuan, what about the last question? The last question, remember, the last question is the 7, the 8, the 9, or a 10. And if you take all this thing here, you add them up, it will give you that item. And if you take a look at the the other question, which is fewer than 3, meaning again the 0, the 1, the 2. So this table, the only problem with this table, ladies and gentlemen, the only problem with this table is if you look at this table, is fixed in terms that is only give you the 5%, the 10%, the 20%, the 25%, the 30%, the 40, the 50, the 60, the 70, 75, up to 95. What if the problem, what if the probability of something is 38? We cannot use this table because the 38, we don't have the probability for 38. Okay, so this thing here, this table is restricted to just this probability because someone have the time in the hand and they just compute the 5%, the 10%, this percent. If they ask you the 65, you cannot have it. They ask you for 55, you don't have it, right? 71, we don't have it. We only restrict to this item. So with that said, this is what you will do. Is the next thing we have is your TI-83 can help you to calculate this item. And to calculate or to use your TI-83, this is what you have to do is you will use the binormal PDF and the binormal CDF, okay? And to do this item, you need to hit on the distribution, which is the DISTR, and by hit second for, okay? So one thing is we will stop here for today. And like I mentioned, I am almost run out of time. We will stop here for today, and I will post a video related to how to use your calculator. And hopefully over the weekend and over the break, you guys look at